start, before we go ahead with the speaker for today, Dr. Ir-Wan from UNP, I would like to briefly introduce about the speaker. Okay, his full name, Dr. Muhammad Ir-Wan bin Adianto, is currently employed as a senior lecturer in Department of Civil Engineering, College of Engineering at University Malaysia Pahang. With PhD in 2016 from Institute of Science Malaysia. Before that, he graduated with a degree in civil engineering, also from USM. After his graduate degree, he worked as a graduate engineer at Zari Associates in Berhad, before continuing in master in civil engineering at USM and graduated with master in 2000. For those interested to work or to do research with Dr. Ir-Wan, Dr. Ir-Wan's expertise is in the field of earthquake engineering, seismic design, structural seismic design according to Eurocode 8, repeated earthquake simulation, as well as cyclic loading tests. He has qualification from IEM and also Board of Engineers Malaysia, and he managed to have 2 grants before this entitled Estimation Model of Weight of Steel in Building with Seismic Design in Malaysia, as well as numerical simulation of probabilities seismic hazard assessment and vulnerability study on existing structure in. Okay. Throughout his experience before this, Dr. Ir-Wan has the opportunity to experience firsthand the event in after the Ranau earthquake on on the 5th June of 2015. Okay, normally when we have earthquake or disaster, we try to run away from the disaster, but we go to the disaster place. So I believe we can learn a lot of things from what happened in Ranau earthquake and what we can learn from experience and how to better prepare for any disaster, especially in earthquake in the future. Without further ado, I would like to invite my dear friends, Muhammad Ir-Wan bin Adianto, to share with us his first-hand experience from the Ranau 2015 earthquake. With all due respect, Dr. Ir-Wan, you are welcome to share your experience.
Okay, so again, very good morning to all of you. First of all, I would like to say thank you very much to the University Malaysia Perlis and University Malaysia Sabah for inviting me to give this talk about the lessons to learn from the 2015 Ranau earthquake. First of all, I also like to acknowledge the University Science Malaysia and the University Technology Malaysia because this is the joint work which is we combine both experts at that moment to work together. On the 5th June of 2015, a moderate earthquake with magnitude of 6.0 as reported by the MMD was occurred in Sabah around 7:50 AM local time. The epicenter was located at 16 kilometers northwest of Ranau, and the depth is about 10 kilometers beneath the earth. The tremors also felt in Ranau, Tambunan, Pedalaman, Tuaran, Kota Badu, and Kota Belud, as well as in Kundasang. Okay, here is the graphical view by Professor Felix Tongkul. This is what I just to repeat again what had been delivered by Dr. Shina last week about the terminology in earthquake engineering. This is the epicenter of the earthquake, and this one we call as, anybody know? Okay, we call as focus, and this is the focal depth, which is around 10 kilometer. Okay, and so this is the focus, and this is the main fault. Okay, the main fault, and it directly to the donkey's ears of the Mount Kinabalu. Okay, you can imagine with the very, very large energy release, it destroys the donkey ear. This is the before the earthquake, and this is after the earthquake. The donkey ear here is dipatahkan. Alright. So after the main shocks, there are several tremors known as the aftershocks occurred in the region. This is the main shock. Initially, they declared as 5.9, but after calibration, it is 6.0 and under category of moderate earthquake. Okay, and this is the aftershock. Okay, you can see the time. 7:15 is the main shock. 7:22, 7:28, and next day is 6th of June. Already occur 4.5. And then this 6th June, I was there in 6th June. 6th and 7th June, I felt these three tremors. However, it is around 3.0 to 3.7 magnitude and under category of weak earthquake. But I felt this tremor myself, and we ran away from the building to save ourselves. Okay, the event also reported by the local news as well as the foreign news. Okay, which is the Ranau earthquake was the greatest since the 1976, which is in magnitude 5.8, if I'm not mistaken. Okay, so this is we take a look on the seismic hazard map for that region in Sabah. Since 2009 and until 2017, we refer to this map as report in the MOSTI report. We use this map, and the seismic intensity there is around 60 to around 60 to 120 gals. Okay, anybody know how to convert the unit of gal to unit of g, which is the acceleration of gravity? Okay, may I know? Anybody can tell me?
Times 0.001.
Okay, thank you very much. So we have to times 0.001. Okay, good. So let me ask you, if the intensity in here is around 100 gal, so what is the unit in G? Gal is US standard, US United States unit. Okay, so if the 100 gal, what is the unit in G?
0.1 G.
0.1 G. Okay, congratulations. Thank you. So Ranau is located here, which is around 75 gal. So what is the unit in G? 0.075 G. Okay, good. Congratulations. However, after the earthquake in Ranau, we have to revise our map, and we can refer to the national annex. Okay, Malaysia National Annex, but as mentioned by Dr. Shina last week, we can refer to the map. Okay, started by December 2017 up to now. This is the new map of Sabah. So we can see here that Ranau is equal to 16. What is the 16? Somebody know? What is the mean by 16? Okay, good. 16 is 16% of G and equal to? Okay, 0.16 G. Okay, good. Thank you so much. So if the region is located here, what is the intensity there?
0.06.
Okay, 0.06 because this is the contour here is 6% of G. 6% of G is equal to 0.06 G. Okay, incontable load is okay, also 0.06 G. This one is 0.07. Okay, there are a total of 4, if I'm not mistaken. Okay. Okay, sorry. Okay, a total of 4 seismicity cases, 4 level of seismic cases, which is first is very low, the second one is low, the third one is medium, and the last one is high. Okay, may I know what is the level of seismicity cases in Ranau region? In this region, what is the level of seismicity cases? High. Okay.
High.
Okay, good. It's medium. Okay. In
Medium.
Malaysia, we only have up to medium level of seismicity cases. Okay. High seismicity cases maybe in Philippines, Indonesia, Turkey, Italy, and Greece. Also Iran. Okay. And as well as Japan and New Zealand. Okay. If you want to know on how to determine the seismicity cases, you can refer to this video in my YouTube channel later. Okay, so this is the first team of reconnaissance missions. We have two teams actually. Ada dua pasukan. Yang pertama, pasukan pertama adalah is for preliminary survey. Okay, consists of 2 from UTM plus 2 from USM, and then the detailed survey has been conducted by a bigger team, I think maybe around 10 to 15 researchers from various universities in Malaysia. Okay, let me introduce you. First of all, we have here is from UTM, which is Dr. Zamri, and we have from Meteorology Malaysia, Mr. Das. We have our great researcher in Malaysia about earthquake engineering, Prof. Azlan. From UTM, Prof. Azlan Adnan in UTM. And we have somebody from Singapore. And this is me at the moment. Still very young, nearly 18 to 19 at the moment. Okay, and this is Dr. Tan Chi Guan. Okay, both of us was from USM at the moment. And now he's from UM and I also UM 5+P. Okay. So here we go. This is the view. Okay, pemandangan apabila pertama kali kami sampai. Kami ambil flight awal dari Penang. Sekitar pukul 5 pagi, kalau tak silap saya, kami bergerak dari Nibong Tebal pukul 4 pagi. So pukul 5 pagi, 5.30, hampir pukul 6. Flight ke Kuala Lumpur, KLIA 2 dan transit di sana sebelum flight seterusnya pukul 10 pagi ke Kota Kinabalu. And then we met Dr. Zamri and Prof. Azlan in Kota Kinabalu. We moved in one car. Thank you very much for their hospitality. And near the Kundasang, kalau tak silap saya, maybe Mr. Hamim tahu area ni, ada satu kawasan padang yang luas berdekatan dengan satu junction. This is from Kota Kinabalu. And this one is, a roundabout, and then there is this is near the Kundasang town, and there is to Ranau. So di sini ada satu tapak padang yang luas. Kami nampak ramai orang berkumpul ketika itu, jadi kami berhenti. We pull over our car, and then kami perhatikan ada ramai orang berkumpul untuk merhatikan. This is the helicopter by Jabatan Bomba dan Penyelamat, and there's the 2 smaller helicopter by PDRM. As well as so many ambulance and kenderaan-kenderaan polis dan di sana mereka, kalau kita boleh nampak di sini, sebenarnya this is the Mount Kinabalu. Okay, the Mount Kinabalu here, but the weather is not so good. Okay, the cloudy, the weather up there is very bad at the moment. We can observe that around for every 10 minutes the helicopter tried to reach the cuba mencapai puncak Gunung Kinabalu untuk misi menyelamat para pendaki yang terperangkap di sana. Tetapi bila sampai, kami difahamkan bila sampai di puncak, helikopter terpaksa berpatah balik untuk mendarat kerana keadaan cuaca sana sangat tidak bagus, angin sangat kuat, jadi tidak ada ruang untuk mendarat. Okay, this is masa sebelum sampai di Ranau, di kawasan padang ni, kami lalu di puncak kawasan masuk ke Gunung Kinabalu. Apa yang kami nampak masa tu adalah kawasan tu dikawal oleh tentera dan juga polis. sebab sana dah di keselamatan yang tak terjamin, jadi terpaksa polis dan tentera turun untuk misi-misi menyelamat. Okey. Okay, then the importance of assessment, that's why as mentioned by technologist Muiz, everybody run away from that area, but as a researcher, we have to enter, okay? We went to that region to do the assessment, okay? The importance is of the assessment is to determine the performance level, okay? The performance level is to determine the status of the safety of building after the earthquake. It shows the performance of building against the earthquake. So we must evaluate the structural performance so we can determine the status of building, either declared safe for use, need repairing work, or has to be demolished. According to FEMA 2000, FEMA 356, there are three main structural performance, which is immediate occupancy, life safety, and the collapse preventions. Okay, all the performance levels can be measured based on the inter-story drift ratio. Okay, as shown in this table, for the reinforced concrete frame building, this is the performance level, immediate occupancy, and this is what happened at this performance level. Okay, may I know what is the value of inter-story drift ratio for immediate occupancy performance level?
1%.
Okay, good, 1%. This is for immediate occupancy. How about this life safety? How about life safety?
2%.
Okay, good, 2% of drift. And then what is the collapse preventions?
4%.
Okay, 4%. If you want to know in detail, you can also watch to my video later. Okay, and this is what the detail. Okay, for occupancy, okay, the building retained nearly all of their pre-earthquake strength and stiffness for both vertical and lateral force resisting systems. Drift is limited to 1% only, and the building is safe for immediate occupancy. Means after checking, we can occupy the building as soon as possible and do our business as usual. However, for the life safety is when the drift is 2%. Drift means this is your column, and then it will sway to the left or to the right. Okay, the value of sway here, the percentage of displacement, the displacement divided by the total height of the column, this is height, divide by the column total height, and then you multiply by 100, that's your inter-story drift ratio, and then you compare with all the level. If the IDR is nearly 2%, let's say 1.9%, so the level is life safety. Okay. For occupancy, it's safer to implement structural repairs or install temporary bracing. Okay, and option may be not practical due to economical reason. However, for collapse preventions, the large permanent drift is around 4%, and damage had occurred to structure including significant stiffness and strength degradations, as well as degradation in vertical load carrying capacity. So it's unsafe for occupancy because it may collapse due to strong aftershock. Right, so this is the list of sites we enter from 6 to 8, 6 to 8 of June 2015. Okay, a very short time. So a lot of total of 8 sites. Okay, this is the site plan view from IPD Ranau, Masjid Jami Ar-Rahman, SMK Mat Saleh, SMK Ranau, And also SMKA Muhammad Ali Ranau, Hospital Ranau, Chon Chu Kung Temple and the Dream World Resort. Okay, the first site is IPD Ranau. First of all, we must get the permissions from the authority. Of course, the authority is the police, Police Ranau. We hear some briefing from the officer there, and then we enter as we want to. The bangunan balai polis tu is selamat, tapi the bangunan yang mengalami kerosakan ialah bangunan the quarters. Okay, the quarters for the staff. Okay, this is the what you can see that the people still use the tent. They don't want to enter the building because of the aftershock activity is still active at that moment. Okay, kami nampak beberapa keluarga mendirikan kemah dan kerana pada waktu itu aftershock activity masih aktif, jadi mereka tak berani untuk kekal berada dalam bangunan. So as you can see, this is a very large crack on the column. Kita boleh masukkan sebatang pen dalam rekahan. Kalau kita perhatikan, ada sebatang pen di sini. Dan this is the crack, spalling of concrete cover. You can see here, spalling of concrete cover is this one. Spalling of concrete cover is this one. Spalling of cover and shear cracking. This is a life safety. Okay, you can see berapa besarnya concrete cover yang terkeluar daripada joint. Dibayangkan kalau ada orang lalu di bawah dan ketika itu batu dia jatuh ke atas kepala, mungkin dia boleh berdarah atau kepalanya boleh terkorak, mungkin boleh retak. Okay, this is second site is Masjid Jami Ar-Rahman. Sama juga masuk untuk mendengar penerangan daripada pegawai masjid dan local authority. Okay, makluman bangunan masjid ini tidak selamat untuk digunakan. Sesiapa yang masuk untuk bersolat adalah atas risiko sendiri. Terima kasih daripada AJK Masjid. Alhamdulillah, tindakan yang bijak daripada AJK Masjid untuk mengelakkan kecederaan berlaku. Kita bersyukur kerana gempa bumi itu berlaku sekitar 7.15 AM. Maknanya waktu pagi, subuh di Sabah masuk awal ya, Dr. Shina? Dr. Shina?
Ya.
Okey, subuh Sabah pukul berapa?
Sebelum pukul 5.
Sebelum pukul 5 kan? So means this one kalau kita ni maybe dalam suasana yang selepas pukul 8 lah. Okey, suasana selepas pukul 8. So this one kita tengok tak ada orang di masjid. Okey, mungkin cuma Tok Siap saja yang membersihkan masjid hari tu hari Jumaat. Okey, hari tu hari Jumaat mungkin bersiap-siap untuk. Tapi dia pun kalau dia berlaku pukul 11 atau 12 mungkin sudah ramai jemaah yang akan terkena. So alhamdulillah kita tengok bahagian ceiling mengalami kerosakan dan this one heavy damage because kita tengok brick wall dekat bahagian menara ni dia tidak di this one one of the lesson to learn pengajaran yang boleh kita ambil adalah bahagian brick wall tidak ada besi yang menyambungkan antara brick wall dan bahagian kolom. Jadi bila dia vibrate, bangunan dia tidak disambungkan dengan baik, jadi dia down, kena pada bahagian ni. Nasib baik tak ada orang kat sini. Dan sama juga bahagian menara ni dia ada dom kecil. Ini juga mengalami kerosakan yang teruk. Okay. Okay, di SMK Mat Saleh kami jumpa bahagian ni. This is the pounding effect. Kalau kamu dapat perhatikan, bangunan ni ada dua kolom yang berasingan tapi diletakkan secara rapat. Okay, kalau kita dapat perhatikan, bangunan sekolah adalah bangunan yang typical design. Maksudnya design dah ada. Jadi this one, okay, let's say this is a typical design untuk beberapa bilik darjah. Kemudian bangunan yang sama dibina dan dicantum secara bersebelahan. Okey, tidak buat design yang baru, dibina secara bersebelahan. Tetapi dia sambungan di sini dah terlampau rapat. Jadi dia mengakibatkan bila satu bangunan bergerak ke arah kiri, satu bergerak ke arah kanan dan dia akan bergerak balik kedua-duanya bangunan bertembung, and this is we call as pounding effect. You can nampak dalam 2 cm lubang, dan this is sambungan antara staircase ke main building. Okey, apa yang menarik perhatian adalah bangunan yang kami jumpa di sini adalah bangunan quarters yang sudah ditinggalkan. Okey, bangunan quarters yang sudah ditinggalkan sejak tahun 1991 kerana mengalami kerosakan teruk akibat gempa bumi dengan magnitude 5.1 ketika itu. Okey, this is bangunan sudah tak digunakan lagi tapi masih di bangunan SMK Mat Saleh. Dan this is you nampak this is kerosakan yang diakibatkan oleh gempa ketika itu, dan bangunan ini tidak diruntuhkan. Mungkin atas sebab tertentu, saya tak pasti. But for sure, tiada siapa pun dibenarkan masuk ke kawasan ni. Okay, this is satu kolom yang sangat besar. Dia rosak di sini. Di kolom di bahagian bawah. Let's say, okay, di belakang, di bahagian belakang kalau tak silap. Belakang sini. Okay. And then we move to SMK Ranau, di Sekolah Menengah Kebangsaan Ranau. Di atas bukit, cantik sekolah dia. And this is also bangunan quarters mengalami kerosakan, di mana kita dapat perhatikan this is the actual column. Actual column maybe around 225 times 225 if I'm not mistaken. And then it covered by the brick wall. Okay, covered by the brick. Jadi kolom itu akan kelihatan besar. Okay, this is also a lesson to learn, satu pelajaran yang boleh kita ambil, iaitu this type of construction shall be avoided because can you imagine what will happen if this brick fall down and hit somebody's head. Okay, and kita nampak di sini ada rekahan pada tanah sebab bangunan ni di atas bukit, so bangunan tanahnya ada berkah sini. And this is the damage on the beam column joint, falling off concrete cover, and we can see the reinforcement inside. And also we can see, macam saya cakap tadi, ada rekahan di tanah ini dia jatuh. And so this is pipe itu dia terpisah daripada bangunan. Okay. And then this is the
Ir-Wan.
Yes. Yep.
Sorry interruption.
Okay.
Nak minta tolong admit Dr. Lee Hong Ping sekejap, dia ada interested to join our session today.
Okay. Siapa ya?
Sorry for interruption.
Saya rasa boleh saya ni dia okey. Dia auto tapi bila
Yeah,
saya
you.
present rupanya dia tak ni.
Dr. Ir-Wan.
Yes. Okey. Ada seorang lagi nak masuk kot Sekejap ya, dia message saya ni. Okey, so can I proceed? Alright, so this one. Okay, then this is in SMKA Muhammad Ali Ranau. Juga sekolah di atas bukit. Kita boleh nampak ini adalah bangunan quarters. Okay, and this is the agak teruk juga kerosakan. Kalau tak silap saya masa tu cuti sekolah. Okay, kalau tak silap saya masa tu adalah cuti sekolah. Jadi tidak ada pelajar yang sedang berada dalam kawasan sekolah. Okay, tapi bangunan brick wall ni jatuh daripada bahagian atas, bahagian atas bumbung di sini dia sediakan brick wall di sini. Kalau tak silap dia ada sediakan brick wall untuk fire resistance, tapi malangnya no proper bracing, dia tak sediakan bracing yang proper. So the brick wall to stand alone due to the vibrations and the brick wall fall down. Okay, the typical damage here also in beam column joint, and then we can observe the damage on the brick wall. Okay, ini satu pengalaman yang saya ingin ceritakan di sini adalah waktu melawat sekolah tu sekitar jam 12 tengah hari. Okay, kami boleh dengar azan berkumandang daripada masjid di bawah. Jadi kami rehat sekejap bersama-sama dengan guru dan masyarakat sekeliling, sebab masa tu ada lawatan, kalau tak silap saya lawatan daripada Menteri Pendidikan ketika itu, iaitu Tan Sri Muhyiddin Yassin, sebab beliau dijadualkan untuk memang berada di Sabah hari itu, jadi dia melawat bangunan sekolah yang rosak. Jadi kami duduk di sini, you can see, okay, my position is there, Prof Azlan and then another team. Di belakang saya ada satu kolam ikan. Kolam ikan mungkin ikan keli, I don't know, I'm not sure, sorry. Tapi saya dengar dia berkocak lain macam. Tapi saya buat tak tahu saja, saya abaikan. Sebab kita tak biasa dengan keadaan tu, kita abaikan dia berkocak. Apa yang kami rasakan, apa saya tahu, mungkin ikan tu lapar, tak makan. Tapi tak lama lepas tu, around 10 minutes lepas ikan keli tu berkocak, kolam tu berkocak, terjadi satu gempa di kawasan sekolah ni, macam saya katakan tadi, dalam 3.7, 3.7 magnitude ataupun 3.0, saya tak ingat. Okay, 3.7 dan kami semua boleh dengar bunyi, the first sound not from the building, but the first sound is the sound of rock crushing. Bunyi macam bunyi batu dipecahkan dari dalam tanah. And then lepas 2-3 saat baru kami dengar bunyi batu dipecahkan dari atas bangunan, which is this one, bunyi konkrit. Kalau you gunakan mesin testing machine untuk concrete compression test, you boleh dengar macam mana bunyi konkrit tu pecah akibat beban yang kuat. Okey, itulah yang kami rasakan dan kami semua lari ke kawasan yang selamat. Okay, and this is the hospital Ranau. Okay, you nampak the ceiling runtuh and then this is the crack on the brick wall. Okay, typical damage. Okay, within the beam column joint and okay, brick wall jatuh. This one nampak ada sikit ni. This shall be, sepatutnya ada brick kat sini. Okay, sepatutnya ada brick di atas ni. Tapi sebab dia no proper bracing, brick itu jatuh. Dan you bayangkan ketika itu adalah, okay, tengok ni, this is berapa hari bulan ni, 8 hari bulan 6. Okay, ketika itu mengikut pegawai farmasi yang bertugas, okay, di kejadian ni adalah di bilik simpanan ubat farmasi. Dia kata masa tu memang setiap hari dia lalu kawasan tu sekitar waktu kejadian. Tapi hari tu dia tak lalu sebab ada urusan lain, dia tak lalu dan dia sangat-sangat bersyukur sebab kalau dia lalu mungkin kita boleh jumpa dia di bawah timbunan batu ni. Okay, this is bangunan quarters untuk staff hospital di Ranau. Okay, ada yang nak join lagi ke? Okay, this is Chon Chukung Temple, satu temple. Kita nampak bangunan. Di sini kami agak pelik sikit kenapa bangunan tu, kalau bangunan lain kita nampak rosaknya di bahagian bahagian bawah kolom. Okey, bahagian hospital ni saya ada cerita yang lain. Nanti kemudian. Selalu rosak di bahagian bawah, tapi di bahagian temple ni kami nampak satu kerosakan di bahagian atas ni. Okey, bahagian atas ni. So this one, around this one lah. Ini kalau ini kami minta kebenaran untuk ambil gambar dari dalam. So kami nampak besi tu terkeluar daripada kolom ni. So apa yang kami dapat tahu, rupanya bangunan temple tu bumbungnya bukanlah bumbung light material, bukanlah bumbung daripada zinc ataupun daripada steel, tapi bumbung tu is fully concrete. You can see this is concrete, fully concrete. So the mass up there is very big and then it cause the vibration, cause failure to this part of the column. As well as this one, we can see the egg shape of bracing, damage on the brick wall. Okay, next we go to the Dream World Resort. Okay, tempat yang sangat cantik untuk bercuti. Okay, di pandangan daripada bawah, rumah-rumah penginapan dibina. However, one of the building got a very severe damage. You can see here kolom yang sudah rosak dan ada yang patah. Bangunan ni bila masa saja boleh bayangkan kalau bangunan tu di atas ni, bila masa saja kalau ada aftershock yang kuat, dia mungkin boleh jatuh ke bawah. Okay, and then this is the special. Hanya tim pertama saja yang dibenarkan masuk ke sini. Okay, tim yang kedua tak dibenarkan masuk lagi. We can see the landslide, tanah runtuh di golf club. kami dapat maklumat bahawa banyak tempahan dibatalkan sebab tak nak berhadapan dengan aftershock. So kami dapat kebenaran masuk pengalaman naik bagi ni, this one. And then, okay, kita nampak jadi cantilever sebab semua yang lain tu dah terjunam ke bawah. Kita nampak di sini rumput-rumput pun dia seakan-akan bergulung. Okey, satu cerita pagi 7 Jun sebelum pergi buat kerja-kerja assessment, kami tanya dengan seorang pakcik ni. Saya tanya dia apa yang pakcik di mana masa tu. Kata saya di halaman rumah. Apa yang pakcik nampak sebelum gempa? Saya nampak seakan-akan tanah tu bergulung. Kalau you boleh bayangkan tak, kalau you pergi ke masjid, okay, adik you yang mungkin umur 4 tahun, 5 tahun, dia agak nakal sikit, dia masuk bawah kapet masjid and then dia bergulung bawah tu. Okay, itulah yang pakcik tu nampak, seakan-akan tanah tu bergulung dan dia sedikit terangkat daripada kedudukan asalnya. Okay, any question? Minta izin minum sekejap. Bismillah. Okay, so this is typical damage. Okay, berdasarkan 8 site tadi, kita nampak damage tu adalah typical, which is damage on beam, damage on column, mostly was on the beam column joint, and then we can take a look on the failure mechanism, and as well as we can see the damage on the brick wall and on the ceiling. Okay, since our building there was not designed according to any seismic provisions, we only consider the gravity load at that moment. So the damage was heavily on the column and on the joint. So this is known as the weak column, strong beam design. Okay, this is not recommended for the medium. Okay, I mean for seismic region, this is not recommended, and we must change this concept to provide strong column and weak beam design, which means our column must be stronger than the beam. Okay. Okay, the damage on beam, however, we can see that there no critical damage observed on beam, only hairline crack and spoiling of the plaster. Okay, not the concrete cover, it's the plaster, the finishing. Okay, this I enlarge this one. Actually, you can hanya satu garisan yang halus saja. Okay, this is hanya satu garisan yang halus saja you boleh nampak pada beam. The beam is very strong. This one is halus saja sebenarnya, dia tak sebesar ini sebab saya besarkan dia. Okay, this one also only the this is our finishing of plaster. This is also the plaster. Okay, not the structural part. However, on the column, there are 4 stages of damage you can observe. First of all is the hairline crack and spoiling of plaster. Stage 2 is the severe crack and spoiling of concrete cover. Stage 3 is the buckling of longitudinal reinforcement before the crushing of total core and the total failure. Okay, this is example of the hairline cracking and spoiling of plaster from the IPD Ranau, SMK Ranau and Chon Chungku Temple. Only plaster yang terkeluar. Okay, this is also plaster, not the concrete cover yet. Okay, this one is also plaster. Okay, then the severe damage is the crack and spoiling of concrete cover. Here in the joint, you can see the steel reinforcement inside. This is the concrete cover. Also like this column, and this is in Hospital Ranau near the beam. This is the beam and this is the column near the joint. Okay, the region, okay, near the beam column joint we call as critical region. And for seismic design, we must provide special detailing. Okay. Okay, this is from the hospital Ranau. As I mentioned to you before, I have some story from this hospital. Okay, insting yang kuat, gerak hati yang kuat. 8 Jun adalah tarikh sepatutnya kami balik bergerak pulang ke Kota Kinabalu untuk penerbangan masing-masing. Tapi saya mencadangkan masa tu, waktu sarapan pagi saya tengok di phone, sinar harian masa tu mengatakan hospital Ranau rosak teruk. Jadi kami belum pergi ke hospital Ranau pada hari sebelumnya. Jadi kami ambil keputusan untuk masuk ke hospital Ranau, minta izin dan buat lawatan. This is one of the quarters building. Satu column, this is the bottom part of the column. Also critical region here. Okay, near the column joint here. We can observe this is the main reinforcement or the longitudinal reinforcement. And this is the link, okay, the shear reinforcement here. Okay, saya ambil tape dan saya ukur. Distance or the spacing is around 200 mm spacing of shear reinforcement. Okay, for design using BS 8110, it might comply with that standard. However, according to Eurocode, okay, according to Eurocode 8, maximum reinforcement for ductility class medium. For ductility class medium, the spacing for link, spacing of shear reinforcement in column in the critical region shall be not more than 175 mm. 175 mm is the maximum value as recommended by Eurocode 8. In order, okay, this is important in order to give better confinement on concrete. So we must reduce the spacing of we must reduce maybe around here, shall be, to give better confinement of concrete. And also I found that, okay, agak mengejutkan juga kat sini, satu bangun batu yang sangat besar, okay, dijumpai di dalam concrete column. Dan bila dibawa keluar di sini, diukur dia lebih kurang dalam diameter masa tu. Diameter is around 50 mm. Okay, which is over the standard, and this is batu, bukan batu, not the standard aggregate, this is batu sungai. Okay, so be careful. Any question? Okay, we proceed. Okay, then this is the total damage occurred on the column here. Okay, fully damaged, fully separated from the main building. Okay, this one also. This is buckling. This is we call it buckling as of longitudinal reinforcement, and I can see no link provided here. Okay, no link provided here. So the concrete core is crushed heavily. Okay, this is also the same. Okay, I have to close the number of the door. And then the original position is around 1 feet drop due to the earthquake. Okay, and this is total damage also in this minaret, okay, because it support the small dome, but this is fully concrete. And then around 4-inch diameter of column. Okay, this one very short. After the vibration, it failed. Okay, like this one. Okay, and then this is severe damage. Okay, damage on the joint, being column joint. You can see here around we got 40 mm lapping in the joint. Okay, how can this happen? This is for the top, top column, and this come from the bottom column. So how can this happen in the construction practice where the lapping is inside the column? Okay, not outside the critical region. In the real practice, the lapping should be like this one. Okay, this is the beam, and so you have the column. The lapping, you must provide the starter bar over the, let's say this is your critical region. The starter bar must be over, okay, not in the critical region. The starter bar must be provided upper than the critical region, and then this is the another bar from for upper side of the column. So you cannot do the lapping inside the joint. Okay. And also this is a spalling of concrete cover, as I mentioned before. And then this is the severe crack, okay, from the joint. Severe crack originated and then it moved to bottom part of the column. Also this one, severe crack originated from the joint, and this is heavily, okay, this column is, okay, you can see this one. The column is not straight anymore, like it become like this one, okay. So this is over the elastic range, okay, over the, I mean beyond the elastic range. So this is maybe your life safety to collapse preventions, performance level. Further checking has to be conducted.
Ir-Wan,
this is also, yep,
Dr. Ir-Wan.
yep.
Sorry, interruption again. Kita ada orang daripada JKR, Ir-Chu nak join, nak minta tolong
Okay.
terus sekejap boleh?
Okay.
Ir-Chu from JKR.
Okay.
Thank you.
Okay. Ini takut nak cakap ni. Okay, sorry, Ir-Chu. Okay. Alright, sorry. Okay, hello. So can I proceed? Okay, so this one, damage on joint, this one. Okay, so this one, the spalling of concrete cover, as we mentioned before, this is we can see the steel reinforcement inside. The typical damage, okay, we can see typical damage from SMK Ranau, SMK Muhammad Ali Ranau, and then for another school, the damage is typical, okay, which is near the beam column joint, and as well as at the bottom part of the column. Okay, now let's take a look on the failure mechanism. Okay, first of all is the short column effect. As I mentioned before, this is in SMK Masalih Ranau, okay, due to the opening of window. Okay, maybe this is the toilet area, so the window is like this one. But however, this kind of practice produce the short column. Okay, the column is like, okay, seakan-akan column itu daripada atas of the opening to the bottom of the opening, and this is the brick wall. Okay, and then so severe damage here because the bertindak seakan-akan column yang sangat pendek, hanya displacement yang kecil akan menghasilkan interstory drift ratio yang sangat-sangat besar. Okay, so macam this, okay, you can see here, this is the elevation of a regular height column. This is the elevation. Okay, let's say the drift here, displacement 1, this is displacement 1. The total height here is H1. Okay, displacement 1, okay, the displacement 1 is equal to displacement 2. And also this is the column itu bertindak seakan-akan di H2. So displacement 1 over this 2 times by 100, you got the IDR for 1. And displacement 2 divided by H2 times 100, you got the IDR of 2, which is extremely higher than the interstory drift ratio of 1. Okay, this one. So that's why the short column effect will heavily damage the column here. Okay, so we better start to reduce the opening, and then we provide the infill here to protect this column from the short column effect. Okay, any question? Okay, this one is a pounding effect in SMK Masalih Ranau. As I mentioned, seperti yang saya katakan tadi, adalah akibat daripada dua bangunan yang sama, typical design dicantumkan, seakan-akan dicantumkan. Okay, tidak buat design yang baru. Dan okay, like this one, okay, dicantumkan, diletakkan. bersebelahan dan sangat rapat. So when the one move to the left, one move to the right, and then move again, it will collide each other, and then it will this is the product of the collision. Okay. Next is the soft story effect. Okay, this is the frame, RC moment frame, RC moment resisting frame. However, we have infill wall at upper story and at the bottom part of the story, okay, there is no infill wall, okay, which is known as the bay frame. Okay, this is for maybe for parking area, okay, maybe they want to park their car here. However, this create less stiffness. Okay, the column at the bottom part, the stiffness of the column here is lesser than the upper part. Okay, the upper part is stiffer. So as a result, when the earthquake comes, it will, let's say, from the right, so it will move, and then the critical damage will occur here, bottom part of the column, and then near the beam column joint, like this one. Okay, this is the illustration, and then at the upper part is still totally or almost vertical. So this will experience very high inter-story drift. Okay, also this one. Okay, this is very fragile or very vulnerable due to during the earthquake. Okay, this is another lesson to learn. Okay, this is an example of the building. Okay, at the moment the quarters. Okay, no infill here. Very weak region at that. Okay, also this one in Hospital Ranau. Okay, you can see the damage. Okay, near the at the bottom part of the column. Okay, and also this one. Okay, soft story effect. Okay, in SMK Ranau, as well as in SMKA Muhammad Ali Ranau. Okay, this one. Okay, this is also a soft story effect. However, this is quite special because you see that the land is sloped. Okay, not flat. The land, okay, the soil is sloped like this one. So this is also create we call as the short column effect. Okay, this also give the short column effect here, because the drift here, the IDR, let's say this is position A and B, the IDR in B is extremely larger than IDR at A. Okay, and also for the non-structural damages, we have brick wall damage. Okay, this one, the damage, because the brick wall is fully attached on the beam and on the columns. So when the forces comes from left and right, from lateral force, okay, the damage occurred here. Also here, okay, due to compression and compression. Heavily damaged on the brick wall due to the shear failure, according to one paper I read. Due to the shear failure, so the damage occurred on the brick wall at the bottom part of the building. Okay, and also this one, we might give a review for this type of construction, this type of finishing. This is a brick, so we have to avoid this type of finishing, because we don't want. Okay, what can you imagine what will happen if the second or third earthquake, I mean the aftershock occur? This one will topple down and it might hit people down there. Okay, this is very dangerous. And also like this one, okay, as I mentioned before, maybe we can provide steel. Okay, saya difahamkan bangunan masjid ni sudah fully demolished dan digantikan dengan masjid yang baru. Okay, then this one brick wall, also ada brick wall di atas ni. We have a brick wall for fire resistance. This is good for fire resistance, but no proper bracing. The brick wall topple down and this is dangerous because it might hit somebody down here. Okay, like this one, this is the just simple simple gambaran yang ringkas untuk menyatakan apa yang jadi. No proper bracing here. Okay, this is if we have a proper bracing like a beam. Okay, maybe then become proper brick wall, and then the brick wall might not collapse easily. But no proper bracing, the brick wall stand freely. So due to shaking, it fall through the ceiling and then fall down to the slab. Okay, so that's all. That's all from Ranau 2015. Let's back to 2020. That's all from me. Thank you so much. See you next week. Okay, and then you can follow my channel if you want to further study about the earthquake engineering in UNP. You can just follow for free. It's okay.
Dr. Ir-Wan for the insightful sharing. Okay, next week I will cover on the base shear. Okay, today apa yang kita Ir-Wan tadi, kita lihat kepentingan untuk nak design structure terhadap beban daripada gempur bumi jika kawasan tersebut kawasan yang ada bumi, contoh macam Sabah ataupun bukit tinggi di Pahang dan sebagainya. Okey, kita dapat lihat kesan-kesan daripada soft story, shock column, kalau bangunan contoh pounding effect, dan juga efek bila kita punya beam tu lebih kuat daripada column. Okey, itu maksudnya weak column. Tapi kalau kita dalam untuk structure yang earthquake, kita ada load daripada horizontal load, maksudnya dari segi gempur bumi akan kena pada kita punya base of the structure. Dan the base of the structure tu kita akan panggil dia sebagai base shear force, and then kita akan distribute pula at each story. Okay? This base shear force bila kita exerted on kita punya structure tu will cause inter-story drift lah, yang kita akan tengok daripada IDR story drift ratio yang Dr. Ir-Wan mention sebentar tadi. Okay, so untuk next week kita akan tengok sedikit macam mana kita nak kira force due to pada bangunan tersebut, dan yang tu kita akan start berdasarkan seismic map, di mana seismic map ni antaranya yang telah di-explain oleh Dr. Noshina Heriani Aris from EMS in the first lecture series last. Okay, I think that's all from us today. We would like to thank every student from UNP, EMS, and as well my student from UNIMED, and also participants from other place, IR Chu from JKR, Dr. Lee Hong Peng from INTI University, and also student Lim Wei Jia, currently working for Saturn, and many others. So thank you very much and have a good day everyone. Thank you, Dr. Ir-Wan.
Okay, thank you so much. Okay. Bye-bye.